Hello everyone, welcome to DevStandup episode 28. And today our guest speaker is Sébastien. Sébastien is an AWS developer advocate focused on performance simplicity and scalable cloud systems. He is also a conference speaker, AWS news blog contributor, and AWS French podcast host. So he's driven by curiosity and knowledge sharing. He believes in everything should be automatable through the APIs. And he brings like deep experience in AWS and in general in cloud architecture. And today he's going to show his presentation about Swift server side and serverless. And I know that's going to be like a really interesting topic. And I would like to hand over the microphone to Sebastian, and he could spin up the session. So Sebastian, here you are.
Thank you very much. Thank you for having me, folks, for inviting me in your show. I really appreciate that. So you said a lot about me already, so I'm not going to talk about me. I'm going to talk about Swift and Swift on the server, but without server. That's cool. So if I say Swift for random to random developers, if I go in a developer conference and I talk about Swift, people are telling me all the time, oh, Swift, that's programming language that you use for mobile application, for iOS application. And I say, no. And then they look at me really saying, what do you mean? There is another Swift? No, it's the same Swift, but it's not only for iOS application. Actually, Swift is open source now since 10 years. At the beginning, like 15 years ago, yes, it was created by Apple for mostly their platform development, iOS, iPadOS, macOS, you name it. But then they open source it, all the development is in open source, and then Swift spread to other operating systems as well. Now you have Swift on Linux, you have Swift on Windows, you have Swift on embedded device, small microcontrollers. You can run Swift on these as well. It's actually a very good general purpose programming language. And because I'm working for AWS, I was many years ago, I started to be interested about how can I get my cloud functions running inside Swift? How can I deploy Swift on the cloud? And this is what I'm going to show you in this presentation. I made a geeky things. I didn't use PowerPoint or Apple Keynote for my presentation. It's plain Markdown presented with a Rust application in the terminal directly. So on the left side, you have my quote slides, and on the right side, you have an IDE. I'm using Kiro here. It's the AWS IDE, but it's not important for this demo. It's based on Visual Studio Code, so you can do exactly the same with Visual Studio Code or any OpenVS6 based IDE. So if your IDE is Cursor, for example, you will be very familiar with Kiro here. Okay, anyway, Swift server-side serverless. So server-side, I guess it's obvious for you if you're a front-end developer, you most probably need a server-side application, maybe to identify user, most probably for any type of REST or GraphQL API, to store your image, store your video. Amazon S3 is amazing for that. So typically a modern application today is a mobile application or a web app that talks to a server-side backend that talks to any type of either software service or database storage, authentication, and things like that. Problem when you're a full stack developer, when you're mostly for small company or independent developer, is that you have one programming language, one set of tools and software libraries, frameworks for your client side. And then when you go to the server side, you have to learn something different. If you're developing in Swift for iOS, you have to learn TypeScript, Python, maybe Java, to deploy your backend on Linux. So I know there are things like React Native where you can program in TypeScript across the board. It's less true with Flutter. With Flutter, you still have the problem to have something on the backend. And I know that what I'm saying about Swift here can be applied to Kotlin as well. With Kotlin, you can write client-side and server-side application. Here I choose Swift, and I think Swift has a couple of advantage over Kotlin, but I don't want to enter into a war and have hate speech on my Twitter feed after this talk. So the idea is to use the same programming language, same tools, same libraries for client side and server side. So why Swift? First, it's open source. Second, it's super efficient. So it's a programming language which is compiled into a native library. So you don't need a virtual machine like TypeScript, Kotlin, Java, Python to run the code. So it's fast. There is no just-in-time compiler. It's like compiling C or Rust directly to your binary. It has a very low memory footprint. It doesn't stop for garbage collection at random time, which is super important for server. You cannot just pause and freeze the server for a couple of milliseconds or seconds whenever it needs to reclaim memory. Swift uses a system called ARC, automatic I forgot the R, automatic reference counting. So the idea is that the runtime as a counter for each object you allocate, and whenever you copy the reference to that object, it increases the pointer by a value of 1. When the reference goes out of scope, or when you remove the reference, the counter goes -1, and when the counter reaches 0, the memory can be free. So you, as a developer, you don't need to alloc and free like in C. The system does that for you and do that super efficiently. It's type safe like TypeScript, JavaScript, Rust. So it eliminates a whole bunch of errors at compile time. But the compiler doesn't stop there. The compiler also check if you are not sharing some mutable variable, some variable in between threads, what they call concurrency environment, so that you cannot accidentally have two threads writing to the same object. So it also removes a whole bunch of data arrays and other concurrency errors right at the compilation time. So it doesn't even compile. On one side, sometimes it's a bit frustrating, but it saves you a lot of time in production. So one language from embedded device to the biggest server on this planet, because it runs on Linux. The challenge, once you have your binary, you need to deploy that somewhere, and you need to put that in the cloud or on a virtual private server that you ran. And doing that at scale, if you ever have deployed code into production, you know it's complex, you have a lot of dependencies, you have version management, you have scaling. If it is your pet project, your side project, maybe a small VPS is enough. But if your application has success, you will need 2, 3, 4, 5, 10, 100, 1000 server. How do you scale that? How do you replace failed instance? Because everything fails all the time, so the operating system can crash, the hardware can crash. You need replacement for your app. And if your app has periodic usage, like a lot of users during the day, nobody is using it during the night, a lot of users next day, you need to scale out and in to save on cost as well. So, or if you deploy on premise, you have to pay for idle capacity. So fast forward 21st century 2026, with the cloud, there is something called serverless. So with serverless, front-end developer can just publish their code on the server side, and they don't have to take care of everything that I mentioned before, the scaling, the high availability. This is taken care by the platform. And the good news, it costs almost nothing, at least for small projects, pet project or demo, it's zero. My AWS bill on my personal account, it's 0.5 per month. I'm talking in US dollar, not Bitcoin. 0.5 US dollar per month, so it's almost nothing. Serverless doesn't mean there is no server. I said it. I know it might sound obvious, but serverless means you are not in charge of the servers. Someone else do that for you. Someone else will ensure that the Linux is current. It's patched with the correct kernel, correct runtime if you're running, I don't know, Java or Python, that these runtimes are installed. Someone else will take care of the scalability for you. Someone else will take care of the availability for you, and you only pay for what you use. That's the definition for serverless. So it's scale, it's highly available, there is no server to manage, and you pay only for that you use. If you use a service that matches these 4 criteria, then it's a true serverless services. Example at AWS that I know quite well, Amazon S3, it's serverless storage. DynamoDB, it's a serverless database. And the compute is Lambda. Lambda, it's also known as a cloud function. So it's a service that allows you as a developer to write some code, and typically it's Python or TypeScript, but it can be other programming language as well. You just upload your code on Lambda, and that's it. Everything else is managed by AWS. So it's highly available, it's scalable, and you pay only for what you use. There are two billing criteria, two metrics you are going to be billed. One, it's the number of invocation, and it's 0.2 per million invocation, 1 million invocation. So an invocation is calling your function, starting your function, waiting for it to execute. 20 cents per millions of invocation, and some 0.000 something per milliseconds of CPU time. Of course, when you run your function, it will run for a few hundred milliseconds, maybe a few seconds, maybe a few minutes, and you pay for the millisecond of execution. So if we stop the counter at every millisecond. Why it's written on the slide gigabit per second? It's because you can't actually choose your CPU with Lambda. You choose the memory. Yeah, you say, I want a Lambda function that runs inside a micro VM of 256 megabyte or 500 megabyte or 1 gigabyte or more. And if you have more memory, you have more CPU. So depending on the amount of gigabyte of memory that you consume per millisecond, you are charged a bit more, a bit less. It depends on the size of the hardware under the scene. Okay, so that's Lambda. Lambda exists since more than 10 years now. And if you go to the list of supported language, there is one missing actually. There is Java, Node.js, Python, Go, Ruby, C#, and Rust has been added recently. So these are the ones that you will see in the AWS console or in the AWS documentation. But actually there is an open API inside Lambda that allows to embark really any programming language. So if you want, and just for the fun, I did it already, you can develop a Lambda function in Bash shell script. It works. We have a lot of customers that are doing PHP on Lambda. We have customers that are doing COBOL on Lambda. Yeah, it's for mainframe migration. You migrate your mainframe from a proprietary environment to Linux because Lambda is running Linux. So as soon as you have something that can run on Amazon Linux, then it can probably be packaged as a Lambda function. Because inside, if we look under the hood, how Lambda works, every function is deployed in a micro VM. So these are like a virtual machine, but micro. So a smaller kernel, no userland utilities, very limited file system. So we reduce the surface of attacks or errors in there. And it's Amazon Linux running inside that micro VM. I said it already. And inside that micro VM, we spine a process that will pull the Lambda service for new event to catch. And when there is a new event, that process will delegate to your code. Your code do whatever it needs to do, returns an error, or returns a value, or times out. These are the three only possibilities. And if you return a value, the little process running inside the Lambda micro VM will push the result back to the Lambda service that will itself push it back to whoever called Lambda. So that process, that loop, you can write it in any programming language. In Shell, a for loop with curl to get and put the result was enough to have a Lambda function running in Bash shell. So I said it, Lambda is trigger when an event happens. And so what type of event does Lambda support? The most typical event for Lambda function, it's a REST API gateway, especially when I'm talking to front-end developer that have a mobile application. You want a REST API so that the HTTP request coming from your mobile application hits the REST gateway, and the REST gateway will invoke the Lambda function and pass all the parameters, the query string, the cookies, and everything. The Lambda function do whatever it needs to do, maybe connect to one database, two databases, do some computation, and returns a value that goes back to your client. I said it's the most common way to trigger a function, but it's not the only way to trigger a function. It can be a GraphQL request. It can be a message arriving in a message queue. It can be something that happens in a database, like you have an insert, update, delete on DynamoDB, and that triggers a Lambda function. If you are old enough, maybe you remember triggers inside the database. So Lambda, it's like the kind of trigger for DynamoDB. It can run on schedule as well, like every 5 a.m. I want to trigger a Lambda function that will do some cleanup and or collect statistic or prepare a cache or something. So it can be based on a regular schedule as well. But the idea is always the same. You have an event that starts your Lambda function. Your Lambda function does something and returns a value or an error or a timeout. But I hope it returns a value most of the time. So Swift is not in the list of programming language, but I told you can write a Lambda function for any programming language. The only thing you need to develop your Lambda function in Swift is the Swift Lambda runtime. So the Swift Lambda runtime, it's an open source library, which is available on the GitHub from AWS that I maintain. So I'm the main and the core maintainer for that libraries. That will allow you as a developer to write your Lambda function in Swift. And again, why choose Swift and not Python or Node? Or one is because if you are a full stack developer, it's probably the language that you know already for the front end. But there is a reason of performance as well. I told you that with Lambda, you are built by the millisecond of CPU time. So having a very performant language like Rust or Swift or Go does matter for your build because you will probably have more execution time with Java or Python than with a compiled language such as the ones I mentioned. So it's safe because of the memory management and the thread management. It's fast, which is good for your bill for your credit card at the end of the month. If you never saw a Swift project, you can create a Swift project with the command Swift. The command Swift, you can install it from swift.org and you choose your platform, Windows, Linux, or Mac OS, and you download Swift. If you are on Mac OS, you probably have Xcode already, which is a developer tool for mobile application, and Xcode install its own toolchain. So if you have Xcode, you have already Swift available in the terminal. Swift package init for an executable can be also a library, then you give a name. In every Swift project, there is a package.swift that describes the project. It's like the metadata for the project. It contains all the libraries, all the dependencies of your project. And you see here, I can show you on my project here, there is a dependency on the Swift Lambda runtime. That's the only dependency you need to write a Lambda function. After that, it's super simple. The Lambda runtime defines a Lambda runtime object. It's defined into this package. So you just create an instance of that object that you assign to the value runtime. I'm spending a bit of time to explain here the Swift syntax. If you are new to Swift, let define a constant. So you have the concept of variable that you can change, that are mutable, and constant that you cannot change. So let runtime equal Lambda runtime, and then it receives a function as an argument. This is really like a constructor in Java or an initializer. It should have two parentheses with the name of the argument and then the body of the function. But there is one syntactic sugar that allows you, if the only argument is a function, you can just pass the function like this. So this is a function that receives two parameter, that's the input parameter, the event that the Lambda runtime receives to invoke your function, and the context, that's a couple of metadata like the time of the day, like in which region we are running, in which data center, how much execution time we have, where is the logger, what object I can use to provide output to the developer. And this is the core of the function. And it's a very, very, very simple function here. It just takes the string as an event and return the reversed string. Once you have that runtime, you need to run that runtime. So it starts that loop. And it's an asynchronous function that never returns. So there is nothing that happens after that. It only returns if it times out or if there is a fatal error, which should not happen. So 5 lines of code, and you can have your first hello world type of Lambda function. Of course, if most of the time you don't have a string as an input, you have a JSON object. In Swift, if you have JSON object, you need to write struct to represent the JSON object because it's a strongly typed language. The good news is that most AI coding agent can generate that for you very easily. That's boilerplate code. Oh, the lapsus is interesting there. I said Claude. It's boilerplate code that can be generated easily if you have a sample JSON. So here, a more complex example, you receive a request made of a name and an age, a string and an int, and it returns a greeting, which is an hello response that has one field greetings, and then the event is hello request, and the result, the return, is an hello response. Okay, so that's the basic idea for input-output of data structure inside Swift Lambda. I told you before that most of the time you have another AWS service in front of your Lambda function. It might be an API gateway, it might be DynamoDB, it might be the scheduler, it might be Amazon S3. I didn't mention that, but you can have a Lambda function that is triggered whenever you upload or delete a file on S3, it triggers a Lambda function. So all these services are sending to the Lambda function a JSON struct, an event. So we have a library as well in open source that creates Swift structure for all these possible JSON events that your Lambda function might receive from different services. It's called AWS Lambda Events. That's the name of the library. And that's the second dependency I have here in my Swift project. It's a 2 different repository just for management purpose. Swift AWS Lambda event. So it provides a pre-built event for the API gateway, for S3, for DynamoDB, the request and the response. So if I want to expose a Lambda function in front of the API gateway, the type of event that the Lambda function receives is an API gateway request, and the response is an API gateway response. Okay, we don't need to know more, but inside these you will find the path, the query parameter, the user agent, all the HTTP headers will be there, the cookies, everything. And in the response, you give the status code like 44502, 502, something like that. And the body can be whatever you want. Here it's a string, but most of the time it will be another JSON. So that's the idea of the second library, the Lambda event. If I compile this here on my machine, which I will do during the demo, I will get a macOS binary because you cannot see it, but I'm presenting from a Mac. That's great. I love macOS binary, but I cannot deploy a macOS binary on Lambda because Lambda, remember, I told you it's using Amazon Linux. So you need a way to cross-compile for Linux. And there are 2 ways with Swift where you can do that. The first way is to use something they call the Swift Static Linux SDK that brings Linux libraries inside the compiler and tells the compiler to generate a binary for Linux. We choose another way with the runtime. We choose to use containers. Right now it works with Docker and Apple container. In this demo, I'm using Finch. It works as well. But the runtime doesn't know I'm using Finch. It's just an alias on Docker. I don't have Docker installed here. I'm using Finch instead. Because it requires a bit of step, first you need to cross-compile. Then you need to create a zip file with your binary and a very special name for your binary inside the zip file. It has to be named Bootstrap because that's what the Unix running Lambda will search for running. So we create a Swift plugin. A plugin is like a utility that lives inside the Swift ecosystem, and the plugin is called Archive, and it's defined in the runtime. So it comes with the runtime. So if I say Swift package archive, it will create a zip file. And that zip file, I can deploy it. You can use the AWS CLI, you can use infrastructure as code, such as Terraform or CloudFormation or the AWS CDK, or what I'm going to use here, it's called SAM, Serverless Application Model. But basically, once you have a zip file, that's your unit of deployment to Lambda. You can also test it locally, which most of the time you want to do because you never write, or I never write code that works from the first time, even with an AI agent. So if you just type Swift run, it will start a small web server to simulate the Lambda runtime environment. And so from there, you can invoke your function with a post, because this is what Lambda does. It's posting on that specific URL invoke. But you don't need an AWS account for local development. You don't need to deploy to test. You can test directly from your terminal. Okay, I hope you're still there. That's the end of the theory. I explained you why Swift is a good choice for server-side programming, why deploying on your virtual machine is not a good idea. It's better to deploy in serverless. It's cheaper, it's scalable, automatically highly available for me. And I show you a couple of lines of code in Swift to show how to create a Lambda function. But showing on a slide is great. Doing it live is even better. So what I have? On the right side, I have an IDE. On the left side, I have a terminal, which is open on the same directory. Inside that directory, I already created it because it might take a few minutes and I don't want you to wait for stupid things to happen. So I created a project, which is defined in the package.swift here. You see the project name, it's called Lambda Demo. This is just to make some dependencies happy. It's of course, it's not important when we are going to build on Linux. That project contains only one product, an executable that will be called Lambda Demo. And it has two dependencies, the Lambda runtime and the Lambda events libraries. And targets are Lambda Demo with these two dependencies, the package AWS Lambda runtime and AWS Lambda event. That's pretty much. For this project, it should build if we build it. Yeah, you see build complete. I pre-built it already. It's not that fast the very first time. All the binaries are there in build. I'm using an IDE here that maybe you don't know. It's called Kiro. It's the AWS IDE with built-in chats and vibe coding and spec-driven development with a Claude model. You have Claude 4.6, 4.7 there. We are not going to use that. The important things, one, it's based on Visual Studio Code. So what I'm showing you here works with any Visual Studio Code based IDE, the real Visual Studio Code, and all the forks, all the derivative, just like Kiro. You need to install one extension, which is available officially on both marketplace, on the Visual Studio Code marketplace and the OpenVS6 marketplace. It's the Swift extension. It's made by the Swift community in open source. and it gives you access to the tests, if you have tests to run, to the debugger. You can put a breakpoint. Of course, there is syntax highlighting. It can show the documentation for a class just by putting the mouse over it, and you can navigate the source by control clicking. If I control click API gateway response, I go directly to API gateway response here, and I can choose to see and to browse the source code. So that plugin make Swift a real first-class citizen in any VS Code based IDE. It's not absolutely necessary, it's not mandatory, but it makes your life so much easier that you don't want to miss it. My main function, it's a bit more complicated, but not too much that when I show you. So I want to deploy a Lambda function as a REST API so that I will be able to call my API here, curl HTTPS something, blah, 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 and test my Lambda function from there. So I decide to expose it behind a REST API. So the event it's going to receive, it's an API gateway request, and it will return an API gateway v2 response. I prepare new headers to put content type application JSON in my response. I also log from the context object. I receive a logger object, and there are different levels of log. Here I debug that I receive a new message, and I create and return an API gateway v2 response saying HTTP 200 OK with the new header, and the same event as the one I receive. That will give you an occasion to see what type of event I receive when it's an API gateway request that invokes the runtime. And then try a wait runtime run. So that's my Lambda function. So I need to package that as an archive, a zip. There is a sandbox inside the plugin that needs to be disabled so that it can communicate with Finch. And I don't want to lose the time to check if there is a new Amazon Linux 2 Swift Docker image. So let's launch the plugin. The plugins launch Docker. On my machine it's Finch, but it's okay. It will build the Lambda function inside Docker, so create a Linux binary, and then it now create a zip file which is there, and I can use that zip file. Inside that zip file, maybe it's a bit small, but there is a bootstrap. Yeah, I did it before already, but there is a bootstrap file. That's what we have there. Okay. So next step is to deploy that zip file. It's not very large, or it is. Depends on your on your reference. It's 12 megabytes. That zip file is self-contained, so all the Swift runtime libraries are included into the zip file. How can I deploy that? I can go to the console. That's one way. I can use infrastructure as code, such as Terraform CDK. I choose another one called SAM. And SAM use a template there to describe the infrastructure I want. And it will create all that infrastructure for me on the server. So I will explain you what is in template.yaml, but let's first deploy, because it takes like 1 or 2 minutes to deploy. And then we can see what's in the template file. So SAM, it's the infrastructure as code command line that will read the template YAML and create infrastructure for me. So SAM deploy guided because there are tons of options and I don't want to give that all in the command line. So the very first time I type -- guided, so it collects all the information interactively, save all that in a file that it can reuse for future deployment. What is the stack name? So the name of the infrastructure stack I want to create. Lambda demo is really good. In which region I want to deploy that? AWS has more than 30 regions. Deploy to a region where that is close to your customer. That's the way to reduce the latency close in terms of network. So I choose Frankfurt here, also known as EU Central 1. Confirm the changes before to deploy. No, I trust you. Do you allow to create permissions role? Yes. Do I want the infrastructure to be rolled back if there is an error? No, I don't want. No, I don't want to disable the rollback, so the rollback will happen. Oh, this one is super important. Lambda demo has no authentication. Is this okay? I'm going to answer yes there, but I will be after you if you do that in production. Never deploy a REST endpoint without authentication in production. It's okay for a 10-minute demo. By the time you will see that video, this infrastructure, the URL will not be there anymore, and there is no critical information in my code. But this is just for a demo, okay, folks? Let's be serious. Do not deploy REST API without authentication. Do you want to save all that in a configuration file? Yes, called samconfig toml. Yes. For which environment we're going to deploy? I can have multiple environments like dev, prod, test, pre-qualification one. Let's just use default here. So it's uploading the zip file to S3 and now it's applying everything there. So everything there means what? I define a list of resources and I say I have a Lambda function and the name is Lambda demo. How do I know it's a Lambda function? Because I says it. It's the type, it's AWS Serverless function. And the code is there in my build directory. It's the lambda demo.zip. That function will time out at 60 seconds. The handler is actually ignored, but it's the entry point inside the function. So it's bootstrap. The runtime hits Amazon Linux 2. I could have written Amazon Linux 23. It works as well. How much memory do you want? You have interest to keep the minimum amount of memory because it's more cost effective. Here 128 megabytes is the minimum, and I want the architecture to be ARM64 because this is the architecture I have on my Mac. So it's important that if you compile on x64, you deploy on x64. If you compile on ARM, you deploy on ARM. Most modern Mac are on Apple Silicon, so it's ARM, which is a good point as well because ARM64 it costs less money than x64. Then I can give environment variable, the log level, debug, and what is going to call that function? What are the events to call that function? And I give a name. It can be any name I want, HTTP API event, and the type is HTTP API. And that's enough to create an API gateway and wire the API gateway with the Lambda function with all the correct permissions. And then the output, I want the API gateway endpoint URI. There is an I missing there. I. And this is what I have here, API gateway endpoint URI. And that's the API gateway that has been created for me. So, you know what? We are going to test that. Let's curl -v. And yes, I received some JSON back. So the -v shows everything that is sent. We see that the endpoint is HTTP to that there is a get sent on that path with that user agent, blah, blah, blah. That's the response from the API gateway, HTTP to 200, the date. So you know the date and time of we record that video, content type, content length, the request ID, and then the payload. The payload is not very easy to read there. Let's make that a bit more readable. Let's use JS. And oops, wrong shortcut, sorry. And JQ. And now you see the JSON nicely formatted. You have the raw query string, you have the domain name, the stage, the HTTP details. This one went over 1 to 1 1. You have the cookies. If there is any path parameter or stage variable or query string parameter, you can get that from there as well. So that's the payload that the Lambda function receive there. Where is it? Source, main. That's the event here that I return as a response. From there, you have to insert your business logic there, do something with that event, delegate to another part of the code, or do something useful. When you're done with it, you can always SAM delete and the name of the stack that you choose. For us, it was Lambda demo, and it will delete all the infrastructure automatically from there. So if you try the same URL, it will not exist anymore. And that's the end of my demo. That's the end of my presentation. I'm very curious to know what you're going to build with Swift on the server side, with Swift on AWS. I'm available on LinkedIn. I am very easy to find on GitHub, on Mastodon and Blue Sky as well. So please drop a message, say hello, connect, or file an issue on the Lambda runtime if you want something, if you think something is missing, or if you find something that is not working, or just if you need help how to use it. I'm checking the issue every morning, so I will be swift to reply to your inquiries. Thank you very much for having listened to me and watched me. And I'm available, folks, if you have any question.
Yeah, Sébastien, thanks a lot for really interesting topic. I really enjoyed also like the way you are presented that in a really fun way. And I would like first ask Atakan like if he has questions, so then I can ask my own questions as well.
Yeah, it was a very interesting topic. I mean, I also had some talks about on the channel on the previous topics, like moving the things to the Lambda. But I have just wondering. So I know on Swift when it became, especially like recently, they said it became open source, and the it's coming from the Android and stuff. And at that time, I was also got into the checking the Swift like outside of just Apple. And I remember one of like most popular, the server side thing was the Vapor framework. Mm-hmm. So I know that AWS has like this packages where you can drop in for Go and the Python to like make it work well with the API gateway. Does something similar like that exist for the Vapor too?
Yeah. So there are multiple ways to do that. So first, a bit of background and context. There are two major web frameworks in Swift today. One is called Vapor. It's the historical one, the one that has the longer tenure or seniority. And it's much more than a web framework. There is also an ORM if you want to interact with a database. For example, there is a templating system to generate web pages. So it's very, very complete. It goes way beyond a web framework. The other one is a bit more light, more modular, a bit more modern as well. It's more recent. It has just a few years. I think GA 1.0 was 2 years ago. It's called Hummingbird, like the bird Hummingbird. And the majority of the Swift backend developer are using one of these two. And then they deploy either on virtual machines, either inside containers, and they run containers. If it is on AWS, we have tons of ways to run containers. It's ECS or Kubernetes, managed Kubernetes. It's called EKS, Elastic Kubernetes Services. If I link back to your question, can you also deploy these to Lambda? And the answer is yes, either with Vapor, either with Hummingbirds. There is a technical challenge to deploy a web application inside Lambda, because a web application will start its own web server and will wait for someone to call it. And I told you how Lambda works behind the scene. It's not the way Lambda works behind the scene. On a Lambda function, you need to have a process that pulls event from the AWS Lambda service and then make HTTP post to to whatever code you provide, and these frameworks are not working the way like that. So you need like a layer in between. You need something in between the Lambda world and the regular HTTP world. And both Vapor and Hummingbird have an adapter that does exactly that. So it talks with the Lambda side and translate that in regular Hummingbird or Vapor calls. So you can just take a Vapor or Hummingbird app, just add a few lines of code, not too much, and then deploy to Lambda. It works. There is another way. There is a generic adapter that works with any HTTP application. So if you have something with, I don't know, fast API in Python and you don't want to change it to adapt it to Lambda, you can just take that like that. You add what we call a Lambda layer. It's like a library for Lambda, and it will do the translation between the Lambda request and the HTTP request that any web application can be deployed on Lambda. And in the long version of this talk, I do that before showing Lambda. I take a Vapor app, and without changing one single line of code, it's just one line to add in a Docker file, but without changing a single line of code, I deploy the Vapor app to Lambda. It's not the most efficient way to do it. It's a bit more slow because we need to go from a JSON and recreate the HTTP request with the correct query string parameter and make an internal network connection between the layer and the Vapor or the Hummingbird application. So it's not performant, but it's the minimum amount of work that you have to do. It's the easiest way to do. Sorry, it's a long answer for a very good question.
Yeah, thank you very much.
Yeah, I have also a couple of questions. We have like one side project. I know that like for Lambda functions, like there is this cold start. And can you tell me like about how is that with Swift Lambdas? Like, is there also this cold start for it? Or?
Yes, there is still a cold start. The good news is that cold start on Lambda, it's less and less relevant these days because the Lambda team mostly eliminate the two reasons why there is a cold start. So again, a bit of context for those of you that are watching us and doesn't know Lambda. I told you Lambda is a micro VM. And the very first time you deploy your Lambda function and you invoke your Lambda function, we need to create that micro VM, install your code, boot the micro kernel and the minimal Linux environment, and start serving requests. This is the cold start. After the request has been served, the micro VM stays up and running in memory on the physical host, ready to serve a second request. So the second request will be served much more quickly than the first one. The problem with cold start as well is that Lambda will scale and will create more micro VM for you. Or if you are not using your Lambda function for a period of time, we are going to shut it down to save on resource. And when you're going to invoke again, we are going to restart. So even the second call, if there is a long delay in between the first and the second one, the second call can be affected by cold start again. The two things that were causing really slow cold start, sometimes in seconds, was attaching a network interface to your private network, VPC. This has been solved since 2 or 3 years. And the second reason is the time to start your application. So it's still very relevant with Java. I'm sorry, folks, if you're a fan of Java. The time to load the virtual machine and the time to load all the dependencies, all the class, can make really, really long cold start. But for Java, there is a solution as well. It's called Snap Start. So the idea of Snap Start is we take a snapshot of the memory and we save the snapshot and we restore from the snapshot instead of rebooting a new micro VM. So there is only one slow cold start, and after that it's quite fast. Is there a cold start for Swift? Yes. Can you notice it? Most of the time, no. The cold start for Swift is somewhere between Rust and Go. In my benchmark today, Rust is the fastest one to start, and Swift is just after. How much is it for Swift? With my measurement, so it's not a official number from AWS. It goes for hello world, so something as simple as that, around 80 to 100 milliseconds. 80 to 100 milliseconds. So it's acceptable for most applications. I was talking with a developer that has a lot of Lambda function in production for real use case, real Lambda function. I can mention it. It's a music service called SongShift that allows you to migrate or synchronize your playlist between Spotify and Apple Music and Deezer and other music providers. So these things runs entirely with Swift on the server, and he said that the call start time that he observed on his infrastructure are between 200 and 300 milliseconds, which is acceptable also for his use case. So to the question, does call start time exist? Yes. Is it relevant for the vast majority of applications? I would say no. And with Swift, we are in the lower end of the call start time with language like Rust and Go versus the higher end, which is more Java these days.
Yeah, thanks a lot for really brief and really thoughtful answer for that. And yeah, I think I'm done. If Atakan doesn't have any questions, we could wrap up the session here.
No questions from my side.
Nice. So yeah, I would really kind of would appreciate like Sebastian's time and like his efforts like to make the knowledge accessible with everyone across the world. And it was end of DevStandup episode 28. And today our guest speaker was Sebastian, and really thankful for him. And if you'd like to be our next guest speaker, and if you have like some knowledge you want to share with other people, we have the application form under the description of this video. You can fill it up and our team will contact you and you can be our next guest speaker. But apart from that, thanks guys and have a great day. So thank you.
You.
Bye-bye.
Yeah, bye.